Hello, Bob Hughes here with JD Squared. This is the second video describing how to basically use the Madden machine with the new version 2 software. What we're going to be talking about in this one is the consumable groups, the settings, other features that we've added into version 2. The previous video showed you how to start the machine, home it, etc. So let's go ahead and do that. Let's start up the controller. I want to double click on the Mad icon. She's coming up, it's searching for controller. It's found a controller, it's starting up, established its communication lines. What we've done in version 2, we've added features called consumable groups and consumable tracking. And what this means is, whenever you cut a piece of metal out, the consumables are literally the end-all of end-alls. I mean, if you tell your machine that you've got 85 amp consumables and it's set to run at that, but you've actually got 45 amp consumables in there or vice versa, it's a bad day for your metal. You know, nothing's going to cut right. The kerf width will be wrong. I mean, there'll be more slag. It's just a train wreck. So what we've learned is the best way to do that is kind of relieve this pressure of you having to have all the right settings from you having to go look through the books and all. We've moved it into version 2. Now version 2 is setting us up for the really cool features in version 3, where you have program restart, the graphical display and everything. We didn't want to wait for that to roll some of these features out, so we said, you know what, go ahead and roll them out in version 2 right here, and we'll worry about version 3 later. First thing we're going to do, the machine is obviously starting at a raw state. We're going to, like in video 1, we're going to turn on the drives, and we are going to do the cheat, the home cheat that I showed you how to do earlier. And we're going to hit the home all button. Remember, I could cheat by homing Z first, and then I could wrap the machine around. However, there is a crash hazard, so I was very careful when I was wrapping it up there not to let the machine crash. But it did increase the time, or decrease the time that it took me to home the machine. Okay, here we go. We're good to go. We've got a piece of metal loaded. Notice the ground is on the metal, you know. Can't express how important that is. If you're cutting a piece of painted metal, sure, our floating head will pick that up and start cutting, but you better have a ground piece where you got bare metal on your grounding deal, or once again, your cut quality is not going to be good. Here's a rule of thumb. 99.9% of the time, if your cut quality isn't good and your CAM program is generating the reasonable code, what it's supposed to, it's not the machine, it's not the CAM, it's your consumables. You've either got the wrong ones in it, they're wore out, you've got the plasma set at the wrong amperage. There's 1,000 ways to die cutting plasma. That's just a few of them. So what we're going to talk about here is what features do we put in the machine trying to help you not have bad cuts. All right. Let's look at the interface. First thing we're going to do, we're going to go ahead and load up a program. So we're going to click the little file button, and we are going to load up. I have a folder on my desktop called NC, and we're going to load up the Wavy logo program, you know, and there she is. Now this program was generated in SheetCam, and at the top of it, it's going to tell you everything. Plasma 45 amp, you know, the kerf width, everything that you needed to know. Now, we're going to be doing another video explaining exactly what I'm explaining to you right now, which is a screen capture video, so you'll be able to see the screen much better. But obviously, I can't cut plasma in my office in there, so we're out here doing the sister video to that one. Now, what happens is when the CAM program generates the code to make the machine, it's got to know how wide of a slot is it going to cut. That slot, when you see it cut the metal, obviously there's a cut path through it. That slot is called the kerf width. The higher the amperage, typically the fatter the kerf width. So if you generated a program in SheetCam, say, and you said, hey, I'm using 85 amp consumables, it's going to look, for instance, and say that the kerf width is 49 thousandths of an inch wide. Well, let's say we load up 85 amp consumables in the machine and we hit the go button and it cuts out your part, and it's probably not going to be a good cut, but let's just say you did, because remember the speed and feeds and the voltage for tracking were also set in SheetCam or another CAM program. So it's going to cut out bad, and you're going to measure and you go, wow, this doggone part's undersized. What happened? What happened is you hit it with too much amperage and the kerf width increased. So now you know why kerf width is important. So it's incredibly important to make sure that what we're telling the machine we have here and what you generated in your CAM program are the exact same values. If they are not, it's game over. You know, live with what you end up with. So anyway, how do we try to make that a little bit easier for you? First thing we're going to look at in the lower left here, you're going to see a box called Plasma Settings. And across the top, there are 4 buttons that are labeled Consumables, Material, Quality, and Thickness, because that's really all you care about, right? What the heck am I cutting? You know, what consumables do I have in the machine? Do I have 45s or 85s, or do I have fine cuts, etc.? And it's going to let you get these choices, but it's only giving you the choices that, for instance, in this case, since we have a Hypertherm PowerMax 85 on there, it's only giving you the choices that plasma is capable. If you've got a thermodynamics unit on there, or ESOB, or somebody else's, we will create the tables for you free of charge and all, and you'll be able to also pick those settings for your plasma unit. But we've done one thing further in version 2. We've made it to where you can create the tables easy peasy by filling in the form and then saying add table or create a new table. Why do we need these tables? We want these tables because we have the functionality now to where you can experiment on your machine, come up with the cuts that you're absolutely in love with, which may not agree with the tables in your CAM program. So by hitting the update table button, we generate a new table that you could then load into your CAM program. Now your CAM program knows the settings that you like. And that's a very important feature. So let's go and start looking at these buttons here. The top left button is Consumable, and it's highlighted right now. Now, if we click on it, it's given us 8 choices for consumables that'll go into a PowerMax 85 in this case. You got fine cut shielded, that's for doing very thin metal, fine cut, unshielded fine cut, and then you have 45, 65, and 85 amp shielded and unshielded consumables. What's the difference between shielded and unshielded? Shielded is your shield on the outside. A shielded consumable is not going to allow the tip to physically hit your metal. It's going to be just below it. It's going to shield it, you know. Why? Well, you got an ohmic machine. You're touching off. You're touching off. You don't really want to be dragging your nice, pretty little orifice, you know, in your tip on this metal. So the shielded one protect it. I myself have never cut with unshielded, but Hypertherm does, you know, list all these different ones. So we have them built into the tables. In the real world, just use shielded and don't worry about the others. But anyway, we have these different settings. Now watch what happens here. If we click, in this case we have 45 amp shielded consumables loaded in the torch of this PowerMax 85. We're now going to select that 45 amp shielded, and it shows you what you got right there, right? Now let's go to the next box and pick material. Yeah, I hope you can see it. Once again, the other videos will show you. You're going to be able to pick mild steel, stainless steel, or aluminum. Those are the 3 materials that they're giving you the settings. Now, once again, in version 2, you can create other metals. I don't know, you know, whatever you want. You can create other metals and update the tables automatically, but that's all they give you. Now, let's say we change consumables. We go to fine cut consumables. We're doing thinner metal, right? Let's do that. Let's go back and pick fine cut. Well, what's happened is now when we pick material, it's only giving you stainless and mild steel. There's no aluminum choice. Why? Because fine cut can't cut aluminum. It's not rated for it. So we took that burden off you of having to experiment, wipe out metal, and then find out, Jesus, I can't cut, you know, aluminum. We've eliminated the choices from you. Now, the choices we've made, you can override, but you're not going to want it. Anyway, let's go back to our 45. Oh, another feature is too, you know, well, I jumped ahead there. Let me go back to my 45 amp shielded. I'm going to pick mild steel because that's what we have loaded right here. The next thing it's asking is the quality. If I click on it, it's giving me 2 choices. 1 and 5. The higher the number, the better quality. Well, the plasma manufacturers will generally give you 2 qualities. Production, which means I want you to cut about as fast as you can. Give me an okay cut. I can live with it. Setting 5 is give me the best cut you can make in this particular metal. So we have already preloaded all that information in it from the manuals and everything that'll allow you to do it. Now, quality, you can, in version 2 of our software, you can create your own tables. And I'll show you that in a minute, easy peasy, to where you might have a quality setting of 3. You don't want to go as slow as best. You don't want to go as coarse as production. You kind of want a little better in production, but you don't need all out. You just create your own tables and call it maybe quality 3. These are features that version 2 is allowing us to do, and then update our CAM program on the fly so you don't have to figure all this out by yourself. Remember we talked about in video 1, for instance, how to override the voltage, the feed. You're hunting for that ideal setting. Well, this is where you're going to make your changes at. In this group down here, you could be hunting for a particular setting, and then you've got it, right? You love it, but it doesn't agree with the manufacturer settings. By filling out the information down in the boxes, overriding what they recommend, we now have a button down here that says update table. You update the table, you now have your values that you know you're happy with, and not what somebody else has forced on you. Real quick, we got the quality settings down. We're going to go ahead and pick setting 5, the best quality. It actually says best, you know. And the next setting here, it's going to give us our metal thicknesses. And right now, it's showing we can cut 0.0179. I'm sorry, I don't know what gauge that is. All the way up to 1/4 inch, but we can't cut higher than 1/4 inch. Why? 45 amp consumables are not rated to go beyond a 1/4 inch. Now, if we had picked 85 amp consumables, for instance, then the thinnest we could have cut would have been 0.134 something, and that's 10 gauge, but it'll give you a max number like 3/4, something like that. So it's very important to have the right consumables for the right metal that you're cutting. In this case, we're going to go down the list, and we're going to select 0.0598. What a weird number, right? 4 decimals. Why would you do that? That's because that's the standards. If you look in the charts for sheet metal thickness, it's not called 60 thou or 65 thou. 16 gauge is called, in steel anyway, it's different for aluminum, different for stainless, it's called 0.0598. So that's your choices right there. You pick that. At this point, down here, all the boxes, it has pulled in the information from the table and said, okay, our Peirce height's going to be 150 thou above the plate. Peirce delay is going to be 0.1 seconds. Cut height's going to be 60. Cutting feed's going to be 350 inches a minute. Rapid's going to be 1 inch, etc., etc. It also telling us that the voltage that it's looking for from the torch height control is going to be 130 volts, you know. Now, right next to it, it has a current box, you know. Well, in our future programs, we're working on this right now, future versions, we want to be able to set the current and the air from our control. However, that requires other communications cables built in to talk to the plasma unit, which we are working on our future upgrades in our software. Now, what it does tell you, though, is current 45. What does that mean? It's not going to set the current, because a Power Max 85 currently, we're not set up to do that, right? Or you might have a thermodynamics, which you can't do it, or an ESOB or something like that. What it's telling you is go back to your plasma unit and adjust the amperage setting to 45 amps. That's what's recommended for this material. You have to manually set it. So we got that done, right? Now, this is where it gets kind of cool here. We have down here a Peirce counter and an arc time. What it is Hypertherm and all these other companies out there will give you an estimated life of the component, what they feel the component's going to make, or consumables are going to do quality cuts up to this number of Peirces and this much arc on time. Well, most people figure this out at the worst possible moment. They're cutting something, all of a sudden their cut goes to crap, you know, what the heck happened? Their consumables are just shot. It's game over, you know? So what we're doing is, let's say you're loading up this beautiful piece of artwork, you got days in this bad boy, and you know, you're looking and go, man, that thing's got, you know, 300-400 Peirces in it. I mean, this is a 30-minute cut. And you look down at your Peirce counter and it says, hey, you've already pierced 240 Peirces. Well, it's pretty much telling you better change the consumables. Well, to track that, we built it into the machine. Well, now you're not guessing anymore. So right now, for instance, it's telling us that this consumable group that's in our machine currently, there's a Peirce count of 27 and arc on time of 18 seconds. Now, if I was to go to a 65 amp shielded, let's say I go get another set that I had used in thicker metal, our program is smart enough to where when you load it and you pick those consumables, it remembers how many Peirces it made, and it's going to track that for you. Now, if you get a brand new set of 65 amp consumables or whatever, put them in the machine, you will click the button called Clear Counters and it will start over. This is hugely valuable. And the reason is our machine has one one purpose in the world, and it's put that torch where it's supposed to be at the right speed, the right height, the whole bit, and do what you tell it to do, what your voltages are, what the kerf is, right? If the cut goes bad and the machine's running fine, you can almost guarantee it's either we got a wrong amp setting there, we got wrong consumables, we got wore out consumables. You could be trying to cut aluminum, for instance, with air. No, don't do that. You know, you're going to have to use nitrogen or something like that. But there's a million things that, like my daughter once said, she goes, there's 1,000 ways to die cutting plasma. Those are some of them. In fact, we feel so strongly about that, we're going to do the whole 1,000 ways to die while cutting plasma video, where we talk about everything from water bubbles on top of the metal and everything else. But right now in this video, let me get back on track here. We're worrying about this right here. Now, since we've got all the settings and we've already done all that, the question is where are these settings at? You know, where's it getting it? If you go to version 2, we go up here to settings and we go over to plasma. We have our different plasma unit where you could select the unit. We have consumables, materials, consumable groups, that's where it's tracking it. And then we have our cut settings. If we shoot over to consumables right here, it's kind of cool because I don't like looking for manuals. I don't want to remember the doggone part numbers of the tip and everything else that's required to do a certain cut. So we've actually added all this to where, for instance, on this hypertherm unit, we've got the name and the part number and what its function is in the manufacturer, so that you no longer have to go hunt for that stuff. If you go over here to materials, we have 3 materials preloaded: aluminum, mild, steel, and stainless. You can add more. Once again, you can add new, you can edit. If we go to consumable groups, this is what we're talking about. So our group names up here, for instance, 45 amp, shielded, fine cut, etc. If we click on one of those right there, it's actually going to tell you the individual part numbers for just that group. So, you know, you don't have to go through this list, figure it out. Just say, hey, I want 65 amp shielded. There's your part numbers. This is what you need to load into the machine. Now, when we go to, and you can also add new once again if you have another different plasma unit or whatever. If you go to cut settings tab, here's where it gets interesting. This is where your qualities, your cut, your units, inches, millimeters, whatever, your material, and your consumables, 45 amp shielded, etc. It tells you your available consumer groups, you know, what is available for that power unit. And I can go and click on stuff and it will pretty much, you know, bring in those tables. So for instance, I clicked on 45 amp shield. Well, I did it on aluminum. Let's go up to, remember, it's very important to get the right stuff. So if I go 45 amp shielded mild steel, quality of 5, there's your table down here. There's 9 entries in it. So let's say you want to add another entry. You go, hey, I don't want to select 0.0598. I want to select 0.060. No problem. Just go ahead, enter the thickness, copy that row, select on that row, change it, and then just say add new. It'll add the row. So from now on, you could type in 60 if you want, but it's using the other values, you know? So this is where you get it. Now, at this point here, once you've got all this gone, working, and once again, here's your table information. You could pick add a new table. I could set my quality at 3 if I want to create a new table, whatever I want to do, different materials. Now, if we go back to run, the update table information, and this is critical. You got to pay attention here. When we update the table, we updated it on this machine, right? Sheet Cam or whatever cam program you're running, currently we really like Sheet Cam, does not know that you've done any of this. It's not on this, you know, it could be on this machine, but there's no direct connection between our table and theirs. So the update table will create the table for your Sheet Cam program. This is why, for instance, we're not really a fan of in Sheet Cam setting a default tool table, because the way it works is if you were going to pick 45 amp consumables for mild steel, that's another group in Sheet Cam, because it looks at different tools as different metal thicknesses and different kerf widths. So that's why you'd want to do that. So the bottom line is, if you update a table here, remember that we're going to need to update the table on Sheet Cam. You know, it's an easy process. There'll be a video on it. It's no big deal, but remember that is critical, you know. Another thing we've done by setting all the kerfs and everything here is we are working on add-ins into our program, standard shape add-ins. For instance, I want to cut a 12-inch circle, right? Does it really matter if I'm cutting that 12-inch circle out of 16 gauge or half-inch metal? I just want a program to cut a 12-inch circle. Well, currently, every machine that we've seen, until you get to the really high dollar machines, and I'm talking six-figure machines, you've got to go and you've got to create a new cam program. Well, what have you done? You've changed the kerf width, you know, because you're going from thin to heavy. You got a heavier kerf, so you move the offset, the lines a little bit further out, and you've changed your voltage, your amp. That's really all you changed. So what we're working on is the new add-ins into this program where all the standard shapes, and if you want to cut a box, a flange, or God knows whatever else you suggest we do, you'll have all these different deals. By using version 2 and further software, you'll be able to go and select your consumables and say, all right, I want to cut that part out, and you never generated a cam program. You haven't done jack. It's going to look and say, okay, well, this is what you got. I'm going to make the program and cut it out to that size. So this is the direction we're heading in our software department, with the sole goal of having the world's best user interface software by the end of 2017. Now that's good news for everybody who has a MAD, because we're never going to charge you for an update. As we come out with new features, you get these features for free. Just because I didn't have time and we didn't have time to write this software when you bought your machine doesn't mean we're going to penalize you, play games with you later, and charge you more money. Every time we come up with something cool, you get it for free. That's very important for us. Anyway, I think we pretty much talked about this right here. Right here we've got 27 Peirce count, and we have an 18 arc on time in seconds. Now, what do we got to do? As it talked about in version 1, machine does not know where the workpiece is. So remember in video 1, I talked about we could preset a previous 0 work coordinate set point, right? Well, in this case here, I'm not going to wrap it. I'm just going to go ahead and hit that button, and here comes our machine to where we had previously set it, you know? Now, this is not going to work for me right here. I don't have the laser option on this machine. You can see the scriber option, but the laser option is currently off it. Let's just go ahead and move the torch over. Whoops, that's why we have 3 different speeds, right? I just moved it a little bit too quick. Let's move over here. And I'm literally, since I don't have the laser on, I'm just gonna walk over here and kind of look at it. I think I need to move a little bit more over on the left, and maybe a little bit more down here, you know? I feel pretty good about that. Once again, I'm going to set the 0 point. That's where I want my X0, Y0 generated out of the cam program, and we talked about that in video 1 and other videos. At this point, I've selected my consumables, I've double checked, I've got 45 amps, I have air, and another feature that, believe it or not, people forget, including myself, is I've got a good ground. I've grounded all my metal. If it's painted, make sure you grind some metal away. You got to have a contact. So looking at the machine, it's as good as it gets. At this point, let's go up to the VCR controls. I have to put on my glasses right here. And then I'm going to hit the play button right here, and off she goes. Now, she's going to cut. You can tell she's not messing around. As soon as it's done here, I'm going to talk about some of the features of, see it moving right here? I want to talk about some of the features of what it's doing. You know, the actual, you know, how does it know where to, you know, how high to move up and down and stuff like that. See right here, she's probing down from 1 inch. In a minute, I'll show you where it will not probe from 1 inch. It'll probe a little more efficient deal. Okay. All right, at this point, we're done. Hypertherm has a delay of when it turns off the gas to clean everything out. We're going to go ahead and we're going to move the torch out of the way. You know, look at her splashing right there. Let's move it back over here where it don't splash, you know. So there's our cutout workpiece right there. Now, if you noticed, when she was wrapping up, it was probing from a 1 inch rapid height, right? Probing down. And that's because it doesn't know where on the plate. You could have flipped up metal, etc. But what we added a feature in version 2, it's called the fast probe height. And when you get done cutting, the machine is always going to raise up to your rapid height setting. And in this particular case, it's set at 1 inch, right? if you're within 2 inches of where it probed last time, it's pretty much going to assume the metal's reasonably close to flat. So what it's going to do is it's going to wrap it over, and it's going to wrap it down to your fast probe height, which in this case is 1/4 inch, and that saves you that time of that torch having to come down at a slower pace to pick that up, you know. So anyway, that pretty much explains everything about the consumable groups. And once again, you need to watch the other video that is a screen capture type video to where you can see the buttons a little bit better. We're not able to cut and do some other stuff out here. Thanks for watching this video. Look for some of the others. Don't forget the 1,000 ways to die cutting plasma. That's going to be very valuable to you. And watch other videos. And thank you very much for your time. Have a nice day.